Now see this question. In this question, the current in a 100 microfarad capacitor is shown. This is capacitor current through a capacitor of 100 microfarad. If the capacitor is initially uncharged, then the waveform of voltage across it is. So we have to draw the waveform of voltage for this current flowing through capacitor. So this is very simple. We know that capacitor voltage is equals to 1 upon C integration I dt. Okay, here current is constant and that is equals to 10 milliampere. So we can write 1 upon C is equals to 1 upon 100 into 10 to the power minus 6 integration 0 to 2 millisecond. And what is current? That is 10 into 10 to the power minus 3 dt. So on solving this we get 1 upon 100 into 10 to the power minus 6 integration 0. When we integrate this we get 10 into 10 to the power minus 3 t limit 0 to 2 into 10 to the power minus 3. Okay, so on solving this we get 0.2 volt. Okay, so the integration of this is 0.2 volt. So what is the waveform of capacitor voltage? See, this is constants. It means the voltage, capacitor voltage is a straight line function. Okay, because integration of this constant is a ramp function. So from 0 to 2 millisecond, this ramp function exists and the final value of this function is equals to 0.2 volt. So here it is 0.2 volt, and after 2 millisecond this capacitor will hold this voltage 0.2 volt, because after that capacitor current is equals to 0. That's why this capacitor will hold this voltage 0.2 volt. So after that this is the waveform. So this is the waveform of capacitor voltage. Now see this question. In this question the waveform of capacitor voltage is given and we have to draw the capacitor current waveform for this capacitor voltage waveform. See, this capacitor voltage function changes its equation in 3 time slots. First, from 0 to 1 second, the equation of this waveform is of straight line. From 1 to 2 second, this voltage waveform is constant, and from 2 to 3 again the equation is straight line with negative slope. So how we can draw the waveform? See, from 0 to 1 second we can write capacitor current IC is equals to C dVc by dt. Okay, and we know that the differentiation of this ramp function is a constant function. Okay, so capacitance value is equals to 100 microfarad. And what is change in voltage? dVc. Change in voltage is 0 to 6 volt. It means 6. And what is time taken to change this voltage? That is equals to 1. Sorry, this is time in millisecond. Okay, so 1 into 10 to the power minus 3. So we get 600 milliampere. Okay, now from 0 to 2 this function is constant. Okay, and differentiation of constant function is equals to 0. So that's why IC is equals to C dVc by dt, and that is equals to 0. Now see, from 2 to 3 second, again this is a straight line function and differentiation of straight line is constant function. So we can again write IC is equals to C dVc by dt. Again this capacitance is 100 into 10 to the power minus 6. What is change in capacitor voltage? Now change in voltage is 6 volt to 0 volt. It means minus 6. And what is time? That is 1 into 10 to the power minus 3. So on solving this we get minus 600 milliampere. Okay. Now we draw the waveform. First we draw the waveform from 0 to 1. From 0 to 1 function is a ramp and its differentiation is constant with value 600 milliampere. So this part of equation has output waveform like this, that is 600. Suppose this is current in milliampere. Okay, time in millisecond. So this is 600 milliampere. Now from 1 to 2 second, this is constant, so differentiation of constant is equals to 0. That's why this waveform is 0. Now from 2 to 3 second, this waveform is again ramp function, and we know that differentiation is constant, and that is equals to minus 600 milliampere. So from 2 to 3, this waveform is like this. Suppose this is minus 600. So this is the waveform of this capacitor voltage. Okay, capacitor current for this given capacitor voltage. So in this way we can draw the various waveform for capacitor. When capacitor current is given, then we can draw the waveform of capacitor voltage. When capacitor voltage is given, we can draw the waveform of capacitor current. So this is very easy. Now see this question. In this question, two characteristics are given. One is voltage characteristic and second is current characteristic. Okay, and we have to find the element for which these characteristics are drawn. So here we can see that voltage is a straight line and this current is a parabola. So it simply shows that current is integration of voltage, and we know that equation of inductor current is equals to 1 by L integration of V dt. So here also current is integration of voltage. It means this element must be an inductor, because this equation only satisfied for the inductor. Now we have to find the value of inductor. Okay, so we can write the equation of this voltage V, that is equals to, we know that y is equals to mx plus c. Here slope is perpendicular upon base, that is 20 by 2. 20 by 2, slope is positive, into t. And what is y intercept? C, that is equals to 0. So it is simply equals to 10t. Now find the integration IL, that is equals to, finally this current IL reached the value 8 ampere in 2 seconds. Okay, so we can write IL is equals to 8 ampere 1 upon L integration 0 to t V dt. What is voltage? That is 10t dt. So on integrating this we get 8 is equals to 1 by L into 10 into t square by 2, limits 0 to 2. Now that is equals to L is equals to 10 by 8, 4 minus 0 by 2. That is equals to 2.5 Henry. So this is very simple question. Answer is 2.5 Henry, and this has been asked in IES 2009.
If you got the knowledge and concepts from this video, then please like the video and subscribe the channel. You can give your views and ask any questions related to this topic in comment box. Also share this video with your friends, because sharing is caring. Don't forget to press the bell icon to get the notification of my upcoming videos. Thank you.